Alright, hey, what's up? And today we're going to be working on the binomial theorem. What is the binomial theorem? Well, in this case, binomial theorem is using Pascal's triangle to expand problems like these, binomials like these with their powers, into full polynomials. So it's basically an expansion theorem, and how we use it is we use Pascal's triangle. And let's go through a little review of Pascal's triangle. It's where you start from 1, and then you basically, like, it's in a triangle where you add them. So you see, over here, you just split the ones over here. And then 1 plus 1 equals 2, and then you keep adding ones to the side. And then 1 plus 2 equals 3, and 1 plus 3 equals 4, 3 plus 3 equals 6, 3 plus 1 equals 4, and so on. And you got, I just wrote down 6 rows, but the rows are really actually infinite. And there's, yeah. So that's Pascal's triangle, and we're going to be using this to expand this into a greater polynomial. So 3x minus 2 to the fourth. How do we use this? Well, we know it's to the fourth power, which means we have to go to the fourth row. Remember that the top row is row 0. So the fourth row is actually the fifth row, and it's right here. Or you could just look at the second number of every row. That's going to be the row number. So over here, it would be 1, 2, 3, 4, 5. But look at the second number, it's 4. So that means we're going to go into this row. So in this row, let's write out the numbers. Those are going to be our coefficients for the expansion. Right, so since it's the fourth power, we got the fourth row. So second number is 4. So that's how you know it's the fourth row, fourth power. And then we got 1, 4, 6, 4, 1. So write those out. Those are going to be our kind of coefficients. And now what do we do from here? Well, we take the first term. So right here it's 3x. And then what we basically do is that we put them in the powers. So like here, it's easier to show than words. So here we put a 3x, and then we put to the fourth power. And now we do it in descending order. So now we put a 3x again, but then we put a 3. 3x again, but then it's a 2. 3x again, but then it's a 1. And then lastly, 3x, but with a 0. And yeah, 0 is just 1, but just leave it like that for now, just for learning purposes. And now we take the second number and we go ascending. So now we got negative 2. So multiply this by negative 2 to 0. Make sure we always put a plus in between all of these numbers. But it's now we're ascending from 0. So now it's going to go 0, 1, 2, blah, blah, blah. So now it's going to be negative 2 to the first. See 0 to 1, 4 to 3, descending and ascending. Let's add that. Negative 2 to the second. And then negative 2 to the third. Let's add that. And then in the end, it's going to be negative 2 to the fourth. And what you always want to make sure is that the two powers or exponents always have to add up to the actual exponent of the binomial at the top, the former binomial. So like 4 plus 0 equals 4, 3 plus 1 equals 4, 2 plus 2 equals 4. That's why we go ascending and descending. So basically for the first term, we descend, second term we ascend, like exponent wise. And now we got this. So now what do we do with this? We got to simplify. All right, so let's get right into simplifying. All right, well, we got 3x to the fourth, which is 81x to the fourth, and then negative 2 to the 0th, which is just 1. So you can cross that out and cross the first one out. So then you get 3 to the fourth, 81. Let me draw that 81 better. X to the fourth. Plus, look here. Negative 2 to the first is just negative 2. And then we got 3x cubed is 27x cubed. And 27 times negative 2 is negative 54. And then negative 54 times 4 is negative 216. So actually, this whole thing is a negative. So instead of that positive, let's change it to a negative 216 x cubed. Don't forget the x. Now let's go on to the next one. Negative 2 squared is 4. And then we got the 9x cubed times 4. So 9 times 4 is 36. And then 36 times 6 is 216 again. So we add 216 x squared. And then negative 2 to the third is negative 8. And then 3 to the first is 3. So negative 8 times 3 is negative 24. Negative 24 times 4 is negative 96. So it's now negative 96 x to the first. Let's just write these out. Let's show which ones go to which. So now we're going on to the last one, which is 3x to the 0. You can just cancel that, that's 1. And the leading coefficient is 1. Negative 2 to the fourth is just 16. So at plus 16. So here's our answer. 81x to the fourth minus 216x to the third plus 216x squared minus 96x plus 16. And that's using the binomial theorem to expand a binomial into the bigger version of it, the full polynomial, using Pascal's triangle. And yeah, let's move on to another example. So here's the second problem, and I decided let's incorporate 2 variables instead of 1 now. And it's not that much different, but let's just get right into it. So we want the third row. So let's keep, I wrote a little draft, but I just wanted to show you how it works. Basically, there's always a 1 here. You always add a 1. 1 plus 1 is 2, and then that's the end. Over here, you add another 1. 2 plus is 3. 2 plus 1 is 3. 1, and oh look, 0, 1, 2, 3. We're on the third row. Look at the second number, it's 3. So now we're going to be using these as our coefficients. So now let's write them out. 1, 3, 3, 1. Those are our coefficients, okay? And now we look, all right, let's look at our first one, 3x. So let's do that, 3x to the third. And we're descending. 3x to the second. 3x to the first. And 3x to the 0. Now, let's go into another one, the last one, which is y. So now, we're ascending. So we start at 0, go to 1, we go to 2, and we go to 3. Let's check that the exponents add up to 3, which is our power for the binomial to begin with. Yes, 3 plus 0, 3, 2 plus 1, 3, 1 plus 2, 3, 0 plus 3 is 3. Yes, we're good there. So now, what we have to do now, make sure to always add pluses in between, is simplify. So now let's look. Y to 0 is just 1, so don't worry about that. 3 cubed is 27. 27 cubed. Now let's see. Y to the first is just y. 3 squared is 9. 9 times 3 is 27. So 27x squared y. Let's go on to the next one. Y squared. 3 to the first is 3x. 3x times 3 is just 9x. So 9xy squared. Last one. 3x to the 0 is just 1. And then y to the third. And boom, that's it. That is using binomial theorem to expand a binomial, like right here. Finding the row, which you can just look at the second number or count down from the beginning row by 0, 1, 2, 3. And then using those coefficients. And then we just plug in the first term, 3x. And then we descend with our exponents, and then we use the second term and we ascend. We make sure the exponents add up to the original exponent. And then yeah, we get the binomial theorem and we expand it out. 3x plus y cubed to get 27x cubed plus 27x squared plus times y plus 9x y squared plus y cubed. And that's the binomial theorem in a nutshell. Hope you learned.